Hello and good morning to everyone. So today we will do the discussion of our exercise 2.4 where we have to apply the factor theorem. Okay? And by the application of the factor theorem, the question may come in the two varieties. One variety it is, you just have to check one variety it is just like this. See, suppose px it is one of the polynomial it is given and here it is another polynomial it is given. See, here it will be asked that you have to check whether this one it is the factor of this one or not. How to check this one it is the factor of this one? Only you have to find out the remainder, it will be how much. Whenever you are getting the remainder it is equal to 0, it means this one it is the factor of this one. Understood? And then after another variety of question it will come that this one it will be said, this one it will be said that this one it is the factor of this one. This one it will be said it as the factor of this one. Factor of this one means already it will be said it as the PA equal to 0. So it means by using PA equal to 0, you have to find out any of the variables. Suppose any of the unknown it is there, k it is there. In that question, unknown k it is there. Suppose any of the variable k, t, s, whatever it will be there, you just have to find out the value. So the second variety of question it will come, you just have to find out the value of the k, otherwise t, otherwise s, for which this one it is the factor of this one. So it means two variety of question it will come. One it is you just have to check whether this one it is the factor or not. How to check this one it is the factor? By checking the remainder it is equal to how much. You know how to find out the remainder. And in the same way, second question it will be asked that this one it is the factor and this one it is the factor, you know it as the PA equal to 0. So from this you can find out if any of the unknown variable is there. Understood or not understood? So first I am showing you the first question. See, first question it is given that check. See, first I am showing you the rough. Here see the rough. Then after from this question onwards, without doing the rough, I will directly proceed. Okay. So here it is given that determine whether x plus 1 is a factor of, check whether x plus 1 is a factor of x cube plus x square plus x plus 1 or not. Check whether this one it is the factor of this one or not. See, this one it is the linear and its degree it is more than 1 also. And our trick it was whenever the remainder it will be 0, then after we can say yes, this one it is the factor of this one. Understood? And in the remainder theorem it was said, have you remembered the remainder theorem? Whenever px it is one of the polynomial, see, whenever px it is one of the polynomial whose degree it is 1, otherwise more than 1, then there exists a real number a, so that x minus a it is a factor. See, x minus a whenever divides this number, see, suppose here it is x and here it is plus 1, I can write it in the form of minus 1. I said, okay, so whenever divisor it is x minus 1, always the remainder it will be our PA. PA means here in place of a, here it is minus 1. So for which instead of doing all these rough work, directly one can write it as the x plus 1. Your writing style should be just like this. See, your answering style should be just like this. See, here it is x plus 1 which is equal to, I can arrange it in the form of x minus 1. Here a is equal to minus 1. Here a is equal to minus 1. So p of minus 1 it is equal to px equal to this one. So p of minus 1 means minus 1 to the power 3 plus minus 1 square plus here it is minus 1, here it is plus 1. See, minus 1 plus 1 cancel. Here it is minus 1 cube means minus 1. Here it is minus 1 square means plus 1. Plus 1 minus 1 it is cancelled, and finally we got that the polynomial value at minus 1, otherwise at 0 of the gx I got it as the 0. So for which yes, this one it is the polynomial, this one it is the factor of this one. Understood? And this question I have done by using our which theorem? Factor theorem. Understood or not understood? So just like this question I have done, in the same way you just have to proceed to do the question number 2. See. Question number 1 also remaining question, you just have to attempt from your side. Okay. Question number 2 it is given. See, Px it is given, first rough work I am showing, 2x cube plus x square minus 2x minus 1, and here it is gx it is given x plus 1, and it is x, this one it is our gx, and this one it is our px. Here it is given that you have to check whether gx it is the factor of the px or not. Actually question number 1 and question number 2 both are of same type, okay. And here it is given that directly gx it was not said, but there it was said that the x plus 1 it is our gx. Understood? So for which here the writing style should be the same. Here only you have to find out the polynomial value at 0 of the gx. 0 of the gx, it is clearly seen it as the minus 1. Otherwise, how we have done the last question in the same way also we can proceed. Your answering style should be just like this. Here gx is equal to x plus 1. So gx, first we have to check, can it be arranged in the form of x minus a or not? Yes, it can be arranged in the form of directly x minus of a minus 1. So here it is the a, it is our minus 1. If you can do it directly just like this, it will be okay. Otherwise you can find out the 0 of the gx. Also from here also you can find out the x it is equal to minus 1. And I have already said whenever the gx it is the linear polynomial where the coefficient of the x it is 1, so it means directly try to find out the value of the a. Okay, whenever other than coefficient 1 you are getting, suppose 3 otherwise 4, so in that case you have to try to find out the 0 of the gx. But here it is clearly it is seen that the a it is our minus 1. So p of minus 1, p of a minus 1 it is our 2 into minus 1 cube plus minus 1 square minus 2 into minus 1, then after minus 1, which is equal to 2. Minus 1 cube means minus 1 into 2 equal to minus 2. Here it is minus 1 square equal to plus 1. Here it is minus 2, here it is minus 1 which is equal to plus 2. Here it is minus 1. Minus 2 plus 2 cancel, 1 minus 1 cancel. Here we are getting the remainder, it is equal to 0. As the remainder we are getting it as the, by using our remainder theorem we got it as the remainder it is equal to 0. But then after we have to use the factor theorem. As the remainder it is equal to 0, so gx otherwise x plus 1 it is the factor of the px. Understood? Perfectly understood or not understood? Thereafter we will do the discussion of the question number 3. Actually in the question number 1 and question number 2, first we got the remainder by using the remainder theorem. After getting the remainder by applying our factor theorem, we just said which one it is the factor of which one. Understood or not understood? Now we will do the discussion of the question number 3. See, in the question number 3 it is given that find the value of k if x minus 1 is the factor of x square plus x plus k. Px x square plus x plus k. So it means it is already said that x minus 1 it is a factor of which one? X square plus x plus k. It means this one it is a factor of this one. Actually this one it is the factor of this one. It means according to our factor theorem, whenever this one it is the x minus 8 is a factor, it means PA it will be 0. It means PA it will be 0. Okay, so PA means here A it is 1. So for which P of 1 it will be 0. As this one it is the factor, so 100% the value of the polynomial at 0 of the divisor it is equal to 0. Otherwise polynomial value at A means here it is 1, it is to be 0. So from this equation we can find out the value of the k. Just see, P1 means 1 square, x means plus 1 plus k is equal to 0. So it means 1 square equal to 1, here it is 1, here it is k, it is equal to 0. So it implies 2 plus k it is equal to 0. It implies k is equal to minus 2. So here it is asked that for which value of the k, this one it is the factor of this one. So your final writing style should be just like this. For k it is our minus 2, this one it is the factor of this one. Understood or not understood? Okay. So in the next step we will do the factorization related few of the question. Okay. Thank you. Have a nice day.